Hello everyone, I'm Bradley Sward, and this is my Day 19, Part 2 solution to Advent of Code 2024. The problem is called linen layout. I'm solving it in Python, pretty much as always here. So from Part 1 of our problem, we have like example of patterns of cloth, and the object was to say, well, how many of these can we make from any combination of the things without breaking them up? Of course, if we broke them up, we can make it work. But just to say, like from this combination, it turns out from this data set that I got 6 of the 8 or whatever. But then for my problem, I had 400 in my data set, and 247 of them were good to go. So then now you're like, well, for part 2, you're like, well, that's great that you told me how many of them can be made of that. But the question is, well, how many different paths can I go to get to there? And that's where things start exponentially going huge on us here. You'll see in a second here my recursive solution from part 1 is now gone, and now it's replaced with something even simpler. But just to say here, like for this one, like this would have been the answer of like, yes, this is, you can make it at least one way, but then you do the math on it and you can do it 6 ways, and then you could do this one 4 ways, and so forth and so on. You can see that for the sample set you get 16. In mine, you're going to get this, how many digits? That's 9, 12, 15, 16 or so digits. I don't know exactly how many. There's no way you're going to calculate that using brute force methodology. There's just no way. You're going to have to think smarter, and that's what this problem is going to do right here. So my code is, there's not a lot of code, and so some of it is similar to last time, but just to say, what do I have here? I know my patterns. My goodness, here, let me get to the top real fast here. I have a ton of them. I think there's like 447 or 448 of them or something like that. It's a huge number of patterns that I can choose from to maybe get me to where I need to go here. And so I have my patterns, I have my tests, basically line for line, and this is just going through one item at a time, one test item at a time, and we're going to try to figure out how many paths each one of them get. We sum them all up, and you'll see we get to the answer. Let me just run it while we talk here, and you'll see that, you can see that, yep, basically it's finding new paths here and there and different ways of getting there, but you can see that, how many times, like you can see those are huge numbers. There's no way you would calculate that over and over and over and over and over. I don't even know how many years it would take to calculate. So anyway, so starting from nothing, as we're doing here, starting from nothing, I'm going to try to add all the patterns to it, the 488, 400 however many patterns to this, and if it's part of the actual word, once I add it to it, I'm going to add it to the list. But basically I'm adding it to the list in one of 2 ways. I'm going to add it to the list, I'm going to add it to the list at the back of the list if it's not in the rest of the list. If there's a duplicate version of that, well, now we have 2 paths crossing and 2 paths coming to the same point, and there's no reason to generate that amount of information twice or 4 times or 8 times or 16. Anything more than 1 time is a waste of time. So we combine the amount of paths that come through that point, and that's what this does. It's like, oh, you're already in the list, then we're going to add you in, and then we're going to add the amounts together. But if I go through the whole list and basically it's a new one, it's something we haven't seen before, well, we're going to add it to the list, but we've seen it however many times up to this point. How many times has this vertex been reached? We're going to continue that down the path. So we're going to add the number of paths in that specific point, or we're going to just basically absolute or relative here, right? So there's my answer. And so basically you just keep doing this, and you also have to make sure here that, like, if the value is the same, that's how we know that we found a path. And if the thing gets larger, we don't need to generate any more data with it. We're just going to let it fall through. But if it's less than, then we continue on, and then either we find what we're looking for, or it's too big or whatever, and eventually we exhaust our search set. I called it left because originally I had a left and a right, and I guess my algorithm didn't need that. I simplified it even more. But as long as there's something still to keep computing, we're going to keep trying, and then we're just going to repeat this, in my case, 400 times. And you can see that, basically, my goodness, look at that one. That is a lot of different ways you can get to that end goal there. And then that's a huge number. So that's my solution to part 2 here. If you know anything better, love to hear it, for the 16 of you who are going to watch this for any length of time. But I appreciate you guys. Thanks for sticking it out. We'll see you in future videos.